Hello gamers, how you doing? How's everyone? Oh wow, the audio is really loud in my ear. One sec. Turn down the earbuds. Okay, now I can hear my own voice. Hey there Sierra, hey there Dima. How you two doing? Whoa. My mouse is going everywhere. Hey there Japio. Yeah, I hope everyone's well. Here, I'll throw on the camera. I've been trying to actually talk to people recently. It's very weird because I have to stare like into the soulless eye of the machine, but there's presumably non-soulless human eyes on the other side of the screen that I can imagine that I'm looking at. So hello, soulful human eyes. I hope everyone's doing great. Before I started the stream today, I was working on finishing up the animations for my next YouTube video. I will give the slightest of teasers for that. Check this out. I've got 6 minutes of animations here that are untimed. Once I actually get the audio in and pace it out, it's gonna be like a 15-minute video, so it's gonna be crazy. You don't have a soul, and you're an AI bot? Jeez, okay, tough crowd. What web app is that? That is Motion Canvas. It's a free and open source code-based animation editor. This is actually the code for one of the animations on screen right now. It uses TypeScript and JSX-like syntax to basically lay out and configure animations, and it's really, really nice. I really like it. But yeah, let's actually go over to the intended project for today. And build up Zephyr so we can actually show what we're working on. So yeah, the last couple streams, we've been kind of working on getting the light propagation system activated again. It was something I first started working on about 2 years ago, actually. If I look at the blame here, it's like May 2023, and I almost had it working. But then I swapped over from OpenGL to Vulkan, and it kind of got lost, mainly because when I started implementing it in Vulkan, I didn't actually re-implement the lighting system into the Vulkan meshes, because it kind of causes conflicts with greedy meshing. As you can see, greedy meshing just isn't even active right now. I do have a solution to make that work, I just haven't implemented it yet. That's a lot of rabbits. What the fuck are they doing down there? Wait, what? Hello? Little guys? Okay, interesting. Sorry. So, the greedy meshing is currently disabled. I do have a plan for getting that back. But the reason it's disabled is because I have re-added the ability for lights to cast light on things and illuminate. If I set the time to night here, you can see we've got, you know, day-night light system. We have light propagation that can be affected by the sunlight. We've got colored lights. If I give myself green light and I like throw it here, we'll see it blends. I can also give myself a red light, although it won't render very well on the cyan grass, but I can put it against the wall here and you'll see that. And I can also give myself a non-colored light, or well, technically colored. These are marginally colored, but they're more like natural. This is my bright light, which is slightly blue tinted, and I can give myself a torch light, which is slightly warm. And you can see that there are different colors. So it does support arbitrary combinations of RGB values. Hey, have a good day. Thank you, Hicarius. I hope you have a good day too. V84L says, is light attenuation based on Euclidean distance rather than Manhattan like Minecraft? Sort of. So that's one of the lighting things that I've done here that I'm really proud of, and it's also causing huge problems. So basically, let me create a perfectly flat area to showcase this. If I just go like, boop, set stone, and then I'm just gonna grab here to here, and then stand up 20, set, that didn't do what I wanted. What happened to the, oh, because I did the syntax wrong. Okay, expand 20 up, set air. Okay, now we got a perfectly flat area. If I give myself a light, and we look up above it. Wow, that is somehow even brighter, or like larger than I thought it would be. Hold on. Let's do this at a bit of a larger scale. Set stone. Just give it a sec to propagate. There we go. Alright. Give Zeus default light cyan. Okay, so basically, the system is still node-based, and it still operates on integer values, so it can propagate around corners and stuff and create shadows naturally like Minecraft. But instead of it just propagating out, so Minecraft's algorithm basically on the like cardinal axes basically goes out by 1 and reduces by 1 each time the light expands out. Whereas my system does that, but also encodes basically the last direction a light came from in its node. Or, sorry, I guess it's technically an additive bit field of all the directions it came from. And basically, so let's say that this node here is the source, and there's no origin, like there's nothing, it didn't come from anywhere, right? Then all of the adjacent 4 nodes here are going to subtract by 2. And then they're going to get a line basically encoded that like it came from, say this is the x direction, it gets a bit that says it came from the x direction. And then nodes that propagate out from this one, if they're going in a direction that it came from, like this, it will also be subtracted by 2. But if they're going in a direction they didn't come from, like this, it only gets subtracted by 1. And what that means is that it expands out in all of the diagonal axes as well, and creates an octagonal shape, which is a lot closer to Euclidean distance. Which was effectively the goal of the system. And I'm honestly really happy with how it turned out. You know, like when you're on really flat surfaces, you can tell that it's octagonal, but I think that like typically when you just look at it, especially on smaller scale lights, it just looks like spheres. But it also has all of the advantages of a node-based system, in that we can easily pull the data values for like mob spawning and stuff. It goes around corners and things without additional computation being required. And it's really cheap to do the colored lighting because we basically just run the algorithm multiple times on each channel individually. However, it's not just like a smoking gun, because if I give myself, I think it's this, and I place this torch. So this is a really small light. If I break it, it goes away, kind of. I mean, that's sort of a problem, but ignore that. If I instead try to break this guy, it goes away. All right, interesting. But what if I destroy this one? Why is it still here? I don't know. So basically, I think there's an issue right now with the way that the removal algorithm works. It doesn't seem to be actually removing consistently. It's especially prominent if I try to do it in an uneven area of terrain. It either doesn't go away at all or creates a really weird artifacting. Like if I give myself a bright light and place it kind of on this ledge and break it, you can see it leaves a bunch of leftover light blobs. And it's really weird, because in theory the system isn't that complicated, right? I'll do my best to kind of create a high-level overview here. So effectively all we're doing, and forgive me because I haven't touched this code in 2 years, is when we have lights in a chunk that need to be processed, then we first iterate through all of the nodes in the remove queue that need to be removed, and then we basically check the existing light at the index that it wants to remove. And if its light value is lower than the value that we've said should be removed, then it deletes it and continues propagating, and otherwise it doesn't, which effectively mirrors how light adding works, where basically you place a light source. I'll give myself the light torch small. It creates a light node on top of it, and then it enqueues all of the neighboring positions, and then basically, while neighboring positions exist, they check this position, and if there's any channel that has a lower light value than what we want to put in there, we put it in there and then propagate out from there, right? And so effectively, it creates like a recursive system. And the process for removing the lights, in theory should be the same exact thing, where we effectively act as though we're re-adding this light, by creating a remove node of its light value right here. And then we propagate outwards like usual, and we remove any light channel that is at or lower than this value, because it should effectively go away if it was influenced by that light in the first place. I feel you. I've been trying to do my own light propagation, and I've been getting all the errors you're getting. Yeah, it gets a little bit crazy. Can I give the voxels Parkinson's? I don't think I'm capable of that. I don't think that I have the ability to imbue status effects on the blocks. Okay, so basically what I want to do is, I'm pretty sure this is a logic problem and not a math problem. I don't think there's anything wrong with the actual logic or like the math of removing light from a node. I think the problem is that the propagator that goes through and tries to remove the nodes isn't handling it properly. But we know that when I'm adding nodes, it's being handled properly, because adding lights works in all conditions. It even works on, like, you know, much less natural conditions. Like, if I give myself the wand back and we go like, all right, let's just dig into this wall, expand 100, set air, and then we make it dark again. This ghost red light here that shouldn't exist still propagated correctly into this tunnel. And then if we were to, like, expand 100 up and set air, now we've got sunlight coming back down from here. So the expansion algorithm is working properly. It's just the actual contracting logic where it should disappear is not. So yeah. Also, I'm actually interested in getting a vibe check here. So the way that my lighting algorithm currently works is when it gets dark, the sunlight is multiplied down. So it basically gets a multiple factor in the shader, where, you know, it gets dimmer, but it doesn't decrease in radius. So you can see that it, like, spreads the same distance, it just gets a lot darker. And in my opinion, that is both a lot easier to program, and it's also more accurate technically to how light in real life works. Like, light doesn't actually spread less far when it's darker, it's just harder to see, right? I'm not a scientist. I could be very wrong, because there is, like, the inverse square law, but that's the proportion of energy, not... I don't know. I mean, technically there's never anywhere where there's, like, no light unless it's blocked, right? So maybe that's correct? I'm just curious what people think, because in, like, Minecraft, you know, the sunlight is just subtracted from on each channel when it gets darker, which means that it actually spreads less distance. But that's hard to do on an RGB basis, because if I have sunlight that's, like, more red than green and blue, and I start subtracting from the actual light values that are being rendered individually, then that's going to end up creating a non-linear color spread where, like, say it starts kind of like, you know, pinkish, then it's going to become more red as the green and blue channels get exhausted quicker by the propagation algorithm. So I'd prefer not to do that if people think it's okay, but if it's a terrible idea, then I'll reconsider. Alright. Oh yeah, I forgot last stream we were currently working on trying to stop the game from seg-faulting when it crashed. Well, that is a journey for another time. I've been making some progress on it. At least we get to unlinking the textures. Okay, so... let's start by taking a look at this algorithm. So we'll start with the light additions, because this should make sense. So... this is an optimization that I'm pretty sure is actually an anti-pattern. I was finding that the add, like when I was propagating the add nodes, it was usually effective to propagate the values that are more intense first. And so I created basically one list. I created an array of nodes for each light value, and I shove it into the correct value, and then I go, or into the correct array, and then I go from the top down. Which makes sense, but I think that it's wasting a lot of memory, especially because these are, what are these? They are queues, which I believe are linked lists under the hood, because They might be vectors. Let's find out. What underlying storage does STDQ use? It uses deck under the hood, and what does deck do? Gotta love C++ documentation. Fast insertion and deletion at both points. Yes, okay, so it is a doubly linked list. It says, as opposed to std vector, the elements of a deck are not stored contiguously. Typical implementations use a sequence of individually allocated fixed size arrays with additional bookkeeping. So, I guess not as bad as a linked list, but I'm not super sure that I want that. I kind of just want a normal vector, and I don't think there's technically any reason why we need to pop in the same order that we push. Like, I'm using a queue because I think in my head I was like, well, the first light that goes in should be the first one to be processed. But if we're already segmenting them by their light level, that shouldn't matter. But that is a problem for later, because right now it's still working, and I don't want to get bogged down in optimizing when we don't even have removal functioning properly. So, while the queue is not empty, we grab the light value out of it, and then pop it. What do I use for my model loading? Fast GLTF, tiny GLTF? I use tiny GLTF, I think. Yeah, tiny GLTF. I used to use Asimp, but it was way too heavy. There's no reason to support more than one model, like, system or format, I guess, as long as it's, like, easy enough to convert from one to the other, in my opinion. Okay, so we have the light value, then we pop it from the queue so that it's no longer in the queue. Hey there, Ilga, how you doing? So then we grab, so basically if the light is 0, then we skip it, which I've commented here 21 months ago as unnecessary. I assume that's because I somewhere prevent it from expanding the nodes out if they're 0. Or it might also be that, like, when I actually go check if the light value is lower, it would never be true because it's 0. Okay, nice. I'm currently in the beginning stage of learning Vulkan, and I wanted to use fast GLTF, but it's not documented well. Tiny GLTF is quite well documented, but it's also a little bit low level. A lot of manipulating buffers yourself. My mesh loader... I guess I have a couple mesh loaders, but I have a lot of code dedicated to it, about 400 lines for the node one. You didn't find a proper Vulkan example. Well, in theory, like, a mesh vertex shouldn't matter, or like the underlying rendering engine shouldn't care about what your meshes are. So, like, if you can find an OpenGL example for yourself, just like swapping out the shader part and like the actual rendering pipeline should be fine. It's all just data under the hood, right? Ah, Elijah, got it. Thank you for helping me, Jared. Okay, so I'm gonna keep this unnecessary call in until we figure out what's going on here. So we get the current light value from the chunk at the correct position. The reason we're doing a multiple by 3 here is because the light is stored as a X value, which is actually a U32. But we need 3 of them per light value. That's why this array is 3 times as long. Because our lights fit into, I think, about 85 bits or something, so we end up just cramming them into multiple unsigned ints. So when we get the existing light value, we pull it out of here and call light copy, which basically does a mem copy into this here, which is just an alias to an array of 3 U32s. So we grab the light from the chunk and we throw it into current light. And then if it's special, which is not going to be handled right now because it's complicated, and I don't think we have any special nodes currently. We do some other shit. And then otherwise, if the light's opaque, then we don't want to propagate into it unless it's special, which will happen if the light itself is a source. Which is an interesting issue here. Basically, in Minecraft, there's this really interesting detail where technically every light source is transparent, even the ones that render like full blocks, like glowstone. So, actually, I can demonstrate this. Let's demonstrate this. We're gonna do a little bit of science. Why am I turning off the lights? I am turning off the lights because it's currently broken. Basically, I have light propagation, but light removal doesn't work. If I give myself a Zeus default light cyan, set it to nighttime, you'll see if I place the light, it gets bright. If I break it, it does not get back dark again. Alright, Minecraft science, check this out. So if I, whoa, okay, thanks camera. Oh, it's already night, perfect. If I create a chamber here, I just go like this, high up enough that like we don't end up seeing the glowstone light at the bottom. And I throw this glowstone up top. You'll see it's dark at the bottom, but if I now go time set 6000, what? Am I wrong? Oh my god, what? Hold on. No, I think it was Mindtest that has this issue. Hold on. Now I need to find out. Give me a sec. Sure, creative mode. Lamp. Nope. Mindtest is such a cluster. Fuck. Okay. Okay, if I dig down a hole here, stick this here. Yeah, see? So the sunlight is still spreading through it infinitely. But like if I put a single block above here, now it's not, right? And that's because basically in Mindtest's light propagation algorithm, I found a dungeon, look at that. In Mindtest's light propagation algorithm, the light would never be able to flow out of this lamp if it wasn't transparent, because it would be captured in the lamp and not be able to spread out of it. Yeah, I did just find a dungeon. Does anyone refer to Mindtest with its new name? I don't. I just don't really care. Maybe I would if I was more actively in the Mindtest scene. Am I on GNOME? Yes, I'm on Endeavor OS with the GNOME desktop environment. Maybe it works different from Skylight compared to other light sources. I mean, that's basically what I was demonstrating there. I guess it's not how it works in old Minecraft. I wonder if modern Minecraft has the same behavior, because I swear it worked like that in Minecraft. We'll give it a quick shot, just to either prove or disprove my point. But at the very least, you saw how in Luanti, in Mindtest, basically it has to have all of its light sources be transparent, otherwise light will never escape them. And we want to avoid that issue. We want to be able to create an environment where the light blocks themselves can be opaque, but we can have light come from them, so that if, like, since we have all these different light channels, say we have a wall of red lights, and then we have a wall of white lights behind it, we don't want it to look like the red lights are white because the white light's going through the red lights, right? When did they do this? That's cool. Glowstone. Okay. Huh. Okay. Looks like they do it better. Cool. Well, TIL, I guess. Educational stream. Okay. So yeah, let's get back to processing through this. What is Mindtest? What do you mean Luanti? Mindtest is the old name for something now called Luanti, which is an open source project that effectively started shortly after Minecraft, and it was an open source voxel game engine. Oh, see you later. Okay, so yeah, so basically if the node is not special and it's opaque, then we skip it, because we don't want to propagate into opaque nodes that are not sources. And then what we do is we merge the light values. So we merge the existing chunk light and the current light into the chunk again. So basically what's happening here is we have our current light value, we have our value that we're trying to add into it, and then we merge it back into the chunk. And then, special notwithstanding, if the light value that is there now was equal to the previous light value, then we skip it. Now, I do want to confirm... Yes, so this also checks the bits, because remember how I said that a light value stores the bits where it came from? Technically, even if all of the actual lights are the same brightness, if the bits changed, if any new direction bits were added, that means that we have a chance to potentially influence the light that gets propagated out of that node. Because anytime a direction bit is set, the light that spreads in the direction of that bit will be brighter than otherwise. So is equal just directly value compares all of the bits of the light, and it will only skip it if it's exactly identical. And then, this is just for bookkeeping, then we create an array of new lights, which are going to be for each cardinal direction. This one is in the Z direction. Well, I guess both of these are in the Z negative and Z positive. Then this is Y negative. This is Y positive. Y negative has a different algorithm associated with it because sunlight needs to propagate down infinitely. And I can get into how that works a bit later if people are interested. And then X positive and negative are here. So this array basically contains a light value for each cardinal axis. Or sorry, for each direction. So 2 per cardinal axis. Then we grab the local position of the block in the chunk, and then... I wonder if this directive even does anything, because I'm not using GCC anymore, I'm using Clang. I wonder if there's a Clang directive to force a loop unroll. Let's see. I mean, this is just telling me to use templates, which I might do eventually. I could also just use an inline function. Like, if I created an inline function for one of these directions, and then I just pasted it 6 times, that would work, because this is just doing it 6 times. Okay, anyways, I'm gonna actually to-do unroll this loop by making a function. Okay, so then for each of the directions, we pull the position from the adjacent node. So, okay, so that is the offset position, I believe, yeah. Then our check position is going to be our current position plus that offset. And our new light is the light value that we computed up here. Actually, I believe MC Skylight only applies to the highest block in a column, so it makes sense for glowstone to block Skylight. Oh, that makes sense, yeah, because even if glowstone is transparent, it would still... So, you are correct, I believe. But there's also the fact that I'm pretty sure if you have a dark redstone lamp, it doesn't allow skylight through it, like, non-cascading. So I do think they have a different system. But you're right. If skylight was propagating down perfectly, then it stops at the first value, unless it's something like leaves or glass where it's fully transparent. But, you know, those are skipped anyways. So we grab the adjacent light value here, and then if it's 0, we continue. So this is why I think this redundant check is redundant. Where was it? This light is 0, continue unnecessary. Yeah, that is unnecessary, because we should never get light level 0 values in the array anyways, because we don't progress through if the value is 0 in here. But also, even if we did, spreading it out would never actually make anything happen in here because the light value would be equal. So it should stop there. So I do understand why this is unnecessary. My only concern is if maybe the direction bits would still get set by the fact that it came from direction 1. I'm curious to see what happens if I do that. I mean, it looks normal. Still doesn't get removed properly, but, you know, not like I would have expected it to from that. Okay, so we iterate through the lights. If the value is 0, we continue because we do not care. Then we get the index in the check position. And then if we are pushing out into a different chunk, then we... Oh, interesting. Oh, this is a binary, or like Boolean arithmetic. Let me actually like split this out into multiple lines, because I've done something kind of ungodly here. So basically what I've got here is I've got this adjacent index, which is being computed from all of these Boolean expressions. Because in C++ and C, a Boolean true is equal to 1 and a Boolean false is equal to 0. So I do check pos is greater or equal to chunk length signed, and if that's true, then it's a 1, and otherwise it's a 0. Then I multiply it by 2 to make it a 2 or a 0. And all of these conditions should be mutually exclusive. Like, technically, you might say, oh, well, what if it's positive, like, over the chunk boundary on x and y? But because we're only directly processing in cardinal directions, that should never happen. So basically, we get the adjacent index here by basically fulfilling 1 or 0 of these conditions, and pull it out of the chunks list up above, which is populated here. It's an array of 7 values, they all start as null pointers, then we populate the first chunk, and then if we try to pull out a chunk that is currently null pointer, then we grab the chunk, basically causing it to be created if it otherwise didn't. Thank you for the hydrate. Then finally we have a check here for if the adjacent chunk doesn't exist, meaning the chunk itself was unloaded, then we skip it. Which I'm also going to put a to-do here. Should bookkeep pending light operations into unloaded chunks somewhere. Because currently that means if a chunk, or if a light is placed on the very edge of the loaded chunks, then it won't actually spread. We can actually demo that. Let's do a quick demo to prove that. And also actually make sure it doesn't just crash if it's a null pointer. It shouldn't, but we'll see. So if I come over here, and let's just make like a, let's go here, and I'll make a little pillar to prove that this is where I was standing. And then let's go over directly to that tree. Cool, and I'm going to get my wand, and I'm going to set a position right there. And now if we go back to where I was standing, and we set it to nighttime, if we look way into the distance, you can see my wand point. And if I go set Zeus default light cyan, it actually didn't propagate at all. Huh. Oh. Oh, interesting. I guess there's probably a bug where if I place a light block into an existing solid block, then it doesn't propagate. That's very weird. Huh. Also, I realized that my plan to make this work is flawed because I don't currently unload chunks that existed. So we'll do a slightly different experiment. Let's grab this block that is at the edge of the chunk. Okay, and we can see that it was lit up. And now if we go back over there, then we should see once the new chunks generate that they do not have light. Oh. Okay, I'm having a great time failing to demonstrate this, but basically the glitch that happened there was when I reapproach areas that are further out than the generation radius, it clears the chunks and then resets them, which kind of defeats the purpose for us. So let's try it here. Default light cyan. This should be within the radius, and it's on a chunk border. So if I approach and we get new chunks, they work? What? Okay, I guess that does make sense, because I have... Yeah, blocks can exist outside of the rendered area by one chunk. So let's be a bit stupid here. Zeus default light cyan. Okay, so there is a chunk that is loaded here. We cannot see it because it doesn't have a neighboring chunk to basically fill in its occlusion information, but we just set a bunch of lights in it, and as we approach, it should get rendered, and the next chunk's over. Do not have light. See? I proved it. Okay. It finally was proved. So yeah, basically this is a bug, and we can fix this by basically storing the light nodes that need to get propagated out into the new chunks somewhere in like the file system, so that when the chunk eventually gets generated, it does properly expand into that area. So lights didn't used to have physical properties, but now do. They've always had physical properties. I'm currently trying to work on making it so that when I break one of my lights, they actually go away. It's like, you know, if this light gets placed and then I break it, it's still bright. Not good. Okay, so... Hold on, I'm just collecting my thoughts. Okay, so basically, once we finally get through here, we get the maximum channel of the new light, and then we add it to the queue that is equal to the maximum channel, and then it goes. This is basically that bad optimization again, where I'm trying to organize it into arrays that are for its light value. I think if I made a custom data structure, this could be a lot more sensical. But hey, it works for now, right? So basically, that's all the light algorithm. Or that's like the light addition algorithm. And the light removal algorithm should effectively be the same thing. So let's go through the light removal algorithm and see if we can identify any differences. So when the remove queue is not empty, we grab the first node from it, we copy its light value out and delete it from the queue. Then we get the existing light value there. And then if the light value is special and opaque, which means that it is a light source, I guess, then we continue to do confirm this only happens if it's a light source. The reason these functions are kind of obtuse is because they are individual bits that are being set to try to keep the algorithm fast. Like, we don't want to look up the node definition every time we, like, move into a new block to find out if it's opaque, so we set a bit on the light itself for if the light value is in an opaque spot. And similarly with the actual light value for being special here, this is set when a light source is there, or when it's a semi-permeable block that should not allow, say, red through, but does allow green and blue. Basically, is special is set if we do need to look up the node for some information, and is opaque is set if the light value, or if the light cannot spread through a block. But if it's both opaque and special, then it's a light source, I think. Like I said, I last worked on this 21 months ago. Okay, so then we grab the old light, copy the existing chunk light into it, then we remove the chunk light. Interesting. So what is this function here? Oh, that's interesting. My ligature font is making this an arrow shape, but it's actually just a template with a Okay, so clears the channels of the light which are less than or equal to the remove value. Leaves the other channels alone. So... interesting. If I were to guess, I would imagine that this is actually the bug. This code looks a bit scuffed. Basically what we're doing is I have this detail less than, which basically does horrible bit shifting to check if, to create a mask inverse member access operator? What is inverse blend? Wait, what? Inverse member access operator. So this code returns a mask of the components where one value is less than the other. Oh, yeah, flip-flopped. So, yeah, okay, I think that makes sense. And then when we go back down to remove, basically this preserve mask is set if the... What are some coding methods you used 21 months ago that you don't use anymore? Apparently this stuff, I guess. No, I guess if I was to answer that honestly, I've gotten a lot more into functional programming in the last 8 or 9 months. And so I've just been going like really hard into using functions instead of classes when I can. Which is actually interesting because the light system is sort of like that already, basically just because classes wouldn't be performant in this use case. But it's done in a really scuffed sort of way that I wish I didn't do. But yeah, in general, Zeph is an interesting project for me because I've been working on it for like 6.5 years now. And so there are like some files that have existed for almost that entire time. And when I look at them, they're still like, oh, everything's a raw pointer, and all of my logic is like terribly structured, and I was allergic to switch statements for some reason, and it's really messy. So yeah, I guess there's a lot of ways my programming has evolved, but I wouldn't say that this is particularly an example where I would have done it differently now. It's mostly just that I wish I commented it a lot better. So, clears the channels of the light value that are less than or equal to the remove value. So rem is remove. I'm just gonna call that remove because, yeah. Then this returns a less than mask for the components of the light structs passed in. The template argument can modify the offset and length of the mask provided. So, I wonder if I ever use that. Shra. Sure, that's a name. I think that's like the offset, but whatever. So basically, this logic here is... Okay, I think I get it. For some reason you're scared of bitwise logic in code. I think that's a reasonable thing to be afraid of. I'm clearly having trouble with it right now. So I think what's happening, if I'm looking at this right, is I'm basically masking out the values of the each of the lights, and then borrow guard is the carry mask, shifted left one. I don't know why I'm doing that there. And I'm subtracting it from the other value, or I'm subtracting the other value from it. And then I'm keeping the carry mask, which... So I think what's happening is I'm grabbing specifically... I think I get it. So A is being subtracted from B. And everywhere where it's subtracted, if B was larger than A... Ah, yes. Okay. So borrow guard is putting one bit to the left of each of the components. So if the components look like this, where say we've got like you know, let's say that there's 3 bits of light here, and they're like this far in. Basically what we're doing is we're scanning for just these 3 bits, adding a bit here, then subtracting the value from here. So basically, only if that value that we're subtracting from is greater than the original will this 1 get set to 0, because this 1 is effectively doubling the value. And so if we double the value and subtract another value, it will only become less than that times 2, or less than the original value, if we subtract more than what the original had. And then we're screening out just that bit, so let's say that it's stuck around, and then we're spreading it right a bunch to basically create a mask. And this mask is only spread properly if B was greater than A. So I'm gonna write this in here. Returns a mask over each component of the light struct where the component value of B is less than A. I think that makes sense. Let's confirm, because I might have that backwards. So subtract is right here, and we're trying to subtract B from A. So then we get... Oh wait, sorry, that's not the right one. We want remove. So we're trying to check if remove here is less than the input value. Wait, B is less than A. So input value is less than the remove mask? If so, then this is set, which is not what should be happening. And given that this is already working properly in the merge code, I'm going to go ahead and assume that it isn't what's happening and I read this backwards. Because we want to check that the in value here is less than remove, right? Or wait, do we want to check that it's less than remove? We want to check that remove is greater than or equal to the input value, which is equal to the input value being less than remove and then inverting it. Because, yeah, if we want... I'm grabbing my piece of paper to write it down. If we want to know if A is less than B, then that's the same as not B is greater or equal to A. Or not A is greater or equal to B. So we want to check if remove is greater or equal to the light value. And if so, then we want to strip the light value from that point. So we need to set the mask if remove is greater or equal to the light value. So remove greater or equal to B. But technically, so if remove is greater or equal to B, then if we wanted to check remove is less than the light to preserve it, then yeah, so that makes sense. So then if B is subtracted from A, then B will be subtracted. So when I think I'm good because I make a smart front end, and then there's this. I'm barely understanding what I'm looking at here myself. I'm sorry. I think basically what's happening is A is having B subtracted from it. It has a bit set to the left of it, which is our borrow guard. And then we know that if the borrow guard is still present, then B was less than A. So then we can mask out just the borrow guard and then spread it right. So then this creates a mask where B is less than A. Perfect, that makes sense. And then now if we go back to remove, we're checking if remove is less than in, which is then creating... It's preserving it where the remove value is less than the in value, otherwise it's killing it. I think that makes sense. Because basically this is a this is a word-level parallelized condition that's being encoded in these values that basically says for each channel of the light in a value here, is the light value for each channel less or greater than the remove value? Because if remove is less than in, then it is set to false if it's greater. If remove is greater or equal to the input value, then preserve mask is set to false. And then we bitwise and the preserve mask with the initial value to only preserve the values where the input light is brighter than the remove value. I feel like I just, like, ran a marathon in my brain. That hurt to think about. Do you have a GitHub profile? I'd love to check out some stuff. Yeah, it's just at Arrayless, same as the YouTube link on the bottom of the stream there. That's basically my username on every platform, so if you see someone on a platform that isn't me with that name, then you should tell them to screw off and give me my name back. Okay, so now that we know how remove works, and I think this actually does work properly, we should go back into dimension. So we remove from the existing light here where the light, where the remove value is greater or equal to it. So this will basically delete any lights that were being influenced by the light that we're trying to remove. Then we've got this is special here, which we're not going to touch yet. Yes, that is my GitHub. Thank you, Brian. Too slow. Then we need to propagate out the lights. So we use our existing light value, which is the one that we're trying to remove, and then we propagate it in exactly the same way as the add lights. I think so similarly that if I was to select some of this, it should highlight it down below. But it's not. So what did I fuck up? Wait, does it just not do it if it's multiple lines? I think it just doesn't do it if it's... No. There is some degree of difference here, because that should have... No, it is identical. I think it's because triple clicking made a new line select. Cool, you also have a website apparently, which probably wasn't updated for quite some time. I've actually updated it recently, arrayless.com. If you think there's something out of date there, let me know. Because I guess it's been like 2 months since I've posted something to it. But it's hard to make articles, I don't know. Yeah, so now that we know, so we're propagating out the lights here, then we're grabbing the local position, then for each of the adjacent nodes, we get the offset position, and then when you get the new light, then we check, and then we find the adjacent chunk if necessary, and then we add to the remove queue. So that system should work, which is interesting. Why is that not working? I wonder if it's an issue with the maximum value being hit. Because if I go over to the nodes file, then we go to light cyan. Oh, it's only the blue channel that's maxed out. So in theory, if that was the problem, if it was the problem that, like, blue is at its maximum value, then only the blue channel should have stuck around. But still, I do want to confirm that I'm not crazy here. Let's build the blocks, and then build the game, and we'll try breaking this cyan light with one lower value here. I have multiple websites. Did you find my web development site? I'm more or less done that part of my career. It exists, but like, I'm yawning lots today. I'm a little sleepy. I mean, I hate to say it, but my sleep schedule's been completely fucked. And I've been going to sleep at like 4:30 in the morning, and I went to bed at like 2 last night and woke up at 10, and it's been a bit jarring. What graphics API am I using? Vulkan or OpenGL? I'm using... Wait, oh, you're on old.arraylist.com. That's still showing up in SE, in like the search results? I kept that around for archival purposes, but that shouldn't be showing up in my results. I don't see it in mine. You're saying that you found that just by searching my name? Huh, I'll have to update the robots file. Okay, cool. Well, thanks. Good to know. What graphics API am I using? I'm using Vulkan. Yeah, that's weird. I thought I had a no robots tag on that. That was my website for an embarrassingly long time until, like, earlier this year. I think I did it around Christmas time last year. I actually updated the site. And I kept that one around on the same domain under, like, the old subdomain, simply just because I felt like it was cool that it was a piece of history, but I thought it was actually blocked from search results. But yeah, thank you. Okay, so what was I doing? Oh yeah, I wanted to test the cyan light here. Okay, so it's still stuck around even though the light value is 62. So that clearly is not the problem. So I guess the next thing we could look at is, let's take a look at what actually happens when I break a light. When I call setBlock, oh, no one unindexed my site. It's just, I have an old website as well that I wrote a very, very long time ago that's on this domain. And I kept it around, like, still publicly indexed. Or I kept it on, like, hosted, because I wanted to like, be able to link to it in my new site and be like, wow, look how adorable and old it is. But I thought I had it set so that it wouldn't index that page for my name, but apparently it does. And I should probably fix that, because yes, it does say I'm 17, and I think it says I'm still in high school, which is not correct. I graduated with a bachelor's degree like a month ago, so winning. Okay, so let's see. Where is it when I break a block? Let's go to the player file. Thank you. I mean, like, so it's kind of weird. Technically, I haven't done the ceremony yet because I had to do some, like, next level bullshit to do a final course, which involved temporarily changing my program. So I still have the ceremony to go through, but I have finished all of the required courses I need to graduate. So I'm effectively done. I just need to actually do some paperwork stuff to get the paper. But yeah, it's been a long ride, so I'm happy to have it finished, for sure. Okay, so node break here is an interaction, and then we call set node err. Got it. Emit a break event, sure. Am I gonna do a master's degree as well? No, I'm not super interested in academia. I mostly did the degree because I wanted job security. But since then, I went on to start a company with a friend that I met in university, and we're currently building our first commercially like designed video game. It's not Zephyr here. Zephyr is a much larger project that I don't have confidence I can get out anytime soon. We're working on a game called Stardust Frontier, which we're hoping to get out within the next year. Yes, Brian's in the chat. If you're interested in that, what resources do we actually have to show people that? I guess I can send the Discord. If you're interested in seeing that project too, take a look at our Discord server. It's got stuff in it. Okay. I need to go to the Dimension Atlas interface and then set node here. This is getting called with air as the value. Yes, bachelor's in comp sci. With a specialization in graphics and gaming. Not gonna lie, I thought Stardust Frontier was the name of the game and Zephyr was the name of the engine. Ah, okay. I guess I do have a kind of, like, theme with things. Yeah, the engine is Zephyr here, and the working title for the game is Zeus, but I will probably change that at some point because that's terrible for search indexing. And then Stardust Frontier is a completely separate project we've been working on. I'm also a bachelor's student in 4th semester, and I'm far worse than you at coding. Well, don't feel too bad. 4th semester is still really early, like, all things considered. That's your 2nd semester of 2nd year, if you have 2 semesters per year. I learned a lot of stuff in 3rd and 4th year that I didn't know when I was in 2nd about, like, more bitwise stuff, which is not usually very useful, but is very useful in specifically what we're doing today. Okay, so we're setting the node here. The node is going to be air. We grab the dimension, we get the old node, and then if it's different, this is just emitting some events. But the important part is that we call setNode, which is specialized in the client dimension to grab the chunk. If the chunk doesn't exist, we cancel it. Otherwise, we lock the right pointer for the chunk. Then we get the position in the chunk that the block is in, and grab the old node. If the old node is different from the new node, then we set the node to the new node. We delete the metadata. We unlock the chunk. Then we call an event called onChunkChange, which I think just currently triggers a re-render of the chunk in the client. And then we call a recalculate light with the chunk, the index, the node, and the old node. And this is where we want to be. So, in theory, node here should be air, and old node should be the light. Let's confirm that. We're gonna go recalculating light because new node def.identifier and old node old def.identifier. And we should see when I break a cyan light, new node Zephyr air, old node Zeus default light cyan. 4th year, well in Germany we have 3 years, but many students study longer. Oh, interesting. So how many semesters do you have per year? Give Zeus default light cyan. Okay, place it, break it. Recalculating light because new node Zephyr air, old node Zeus default light cyan. Okay, confirmed that this is a thing that is happening. 2 semesters. Oh, interesting. How many courses do you have per semester? Because that means, yeah, you've got 6 semesters total. Wow. I wish my schooling was only 3 years. It's a 4-year program here, but, like, pretty much everyone takes it in 5 years because they expect you to be taking a kind of ridiculous number of classes at once. My degree, I think, it ended up taking 5 years. I was scheduled to graduate in 4.5. But then I got a job offer and went and did a job for 8 months while only taking, like, the minimum number of classes to stay in my degree. Saved up some money to do this whole commercial project thing that we're doing, and it delayed my graduation by a little bit. Okay, so if the old definition emits light, which should be the case, or it was transparent, or, yeah, if the old light was transparent and the new light is not transparent, basically we're saying, so if light could have been passing through this block that was affected by the old definition, then we lock the right pointer, we copy the chunk's old light, then we set the light to opaque here. That's interesting, because this doesn't set it to 0. So in theory, that's storing the old light value while also setting it to be opaque. That might be our bug. I got my graphics masters in 1 year in the UK. 1 year? Oh, after 3 years comp sci. Then went straight to work as a graphics programmer. That was before the games industry went belly up. Interesting, so it was a 3-year bachelor's, then a 1-year master's. Huh. I don't actually know how long a master's is here. I think it's 2 years on top of your bachelor's, but maybe Brian can correct me if I'm wrong. When you take 30 ECTs or credits, you can do it in 6, so courses are weighted by workload. Interesting, so it's not linear. Huh. To all students here, see if you can find a programming club at your post-secondary. Yeah, no, that is really important. I have lots of opinions about university education, at least how it's structured for learning video game stuff in my part of the world. And I generally think it's really bad at doing that. I came in with like a lot of prerequisite knowledge about like game development stuff, and even though I took a program that was specifically about game development, I feel like I learned almost nothing. So, you know, take that as you will. I do think I learned other more general comp sci stuff, and depending on what you're interested in, that might be useful, but it was very frustrating to me that I learned a bunch of things that had nothing to do with my actual interest area. But like by far and away, the most valuable thing I got out of university was meeting other like-minded people at the game dev club at my university. If you're not already doing extracurricular stuff at your university, don't waste any more time and go do that. Because there's basically no reason not to. It's way easier to associate with people when you're still a student, and you'll meet people that are really cool that you might not have met before. I don't know. I can't recommend it enough. Oh man, so many words. Hold on. I'm missing the YouTube chat. Or sorry, the Twitch chat. Okay. Having personal projects... Okay, wait. Problem is I started on second semester. Interesting. Having personal projects you're interested in to work on outside of uni is a big boost in learning. Yes, it definitely is. I feel like it's almost mandatory, at least in, like, Canada and the States right now. Like, people won't consider you if you just have a degree and no, like, personal experience. Like, yeah, definitely having personal projects is super important. Yeah, okay, in the US, you have a lot of non-major related classes, right? In the UK, our degrees are generally 3 years, but we don't have any classes not related to our major. So I am in Canada, not the States, but my degree had, I think, about 12 courses that were, like, basically just any course. Oh my god, wait, hold on. Huge raid. Sudden raid. Ah! Hey there, Alfalso. Hey there, Miss Trouble. Hey there, Truly Most Wanted. How you doing? The stream now belongs to Miss Trouble. Oh no. Okay, sorry. I'll give you the OBS configuration. But yeah, like, we had, I think, about 12 courses, so 3 semesters worth of electives that needed to be done, but weren't actually part of your, or, like, didn't have to be comp sci related. I ended up doing a lot of comp sci related ones anyways, but yeah. Okay, so I guess for the new people here, just to give a brief introduction, hi, my name is Ari. I've been working on creating a voxel engine for the last 6 years. We're currently working on the lighting system, which has RGB lights. If I grab a red one here and throw it in, it supports RGB lights. Whoa, that was a lag spike. What just happened? Whoa, that's a new one. Okay, it has RGB lights, and they currently do not get deleted properly when you break them. And that is what we're trying to fix. And then we're getting very off topic by talking about university. Thanks, yeah, I'm glad you like it. I've been working a lot on making sure that, like, I want to have a unique design identity, because I know that I'm fighting an uphill battle by making a voxel engine of this style. You know, people are, by default, going to relate it to Minecraft, and that's going to, you know, make a lot of people disregard it immediately. So I'm, like, this is very early stages, but I plan on doing a lot to differentiate it in theme and, like, gameplay. I just really like the voxel space. I think it's super cool to make entirely destructible environments, and I love building and stuff in video games. So it's basically my like favorite medium for creating a game, but I have no interest in just replicating like Minecraft's entire gameplay, if that makes sense. And I guess the start of that is I want to make unique environments that are, you know, interesting. Thank you. Yeah, we were, so before the super tangent, we basically were in a situation where we're trying to figure out why the light wasn't getting removed, right? And the thing that I just hit on here is this, if the definition is not transparent, I set the light to opaque here, but the light being set to opaque is not actually the same thing as it getting cleared. And also, interestingly, that's happening above the light create, which I think it does clear it. Yeah, this completely clears the light. So if we go back to the client dimension here, this line is getting immediately discarded by this line. So maybe let's see what happens if I swap those around. I mean, I don't think that will actually change anything for this bug, or specifically, because we are replacing it with a transparent light. But I mean, it's worth trying. Did I fix floating stuff? Like, did I fix floating block pieces? Oh, see you later, LD. So, I'm not actually particularly interested in removing floating bits and bobs. I actually want to intentionally bring them into the environment of, like, the first area of the game, because I want to have, like, alien floating islands. Like floating trees and etc. Are you talking about how I was having like weird trees in the sky sometimes? Because no, I have not fixed that yet. In fact, it's marginally worse now because they now spawn underground as well. But that should be an easy fix. I think it's basically just an underflow of the local coordinates that blocks are being placed on in the map generator, and I haven't bothered to fix it yet. Okay, so we're setting the light value here to a new light value. Wait. Hold on. Wait, something's weird here. Oh no, I hate floating stuff in Minecraft, but I prefer realistic mod packs. Maybe I'm not your player base. Oh, that's fair. Yeah, I'm trying to make a pretty, like, detailed, alien environment, so I do want to be able to have floating islands. Although I do plan on potentially making, like, there be an actual levitating material that spawns in them to kind of justify it. I don't think that the current generation produces floating islands, though, but that's mainly because it's mostly 2D noise with warping. So there's not really much of a place for that to happen. Is LOD good for voxel games? I mean, I like it. I want to do it. I had a system for it, but it's also not currently implemented right now. A lot of stuff got, like, kind of canned temporarily when I swapped to Vulkan, and then it's still canned from, like, 2 years from then, so... Hold on, I need to quickly figure out what I just did here, because... How it was before was this. Then we go and we set the chunks light to be opaque. Then we create a new light at that opaque spot. So I'm gonna redo that. So basically what happened is if the old definition was transparent, we basically set it to have 0 light, and then we also store whether or not it's opaque. Then we set whether it's special, then we unlock it. And finally we emplace the existing light value into the remove queue. Which is actually weird. I'm not sure why I reset the light here. Because we're copying... Yeah, I don't know why I would do that. Oh, okay, I understand, I think. So I'm setting the opaque value here because we need to know if that block is opaque if the new block was changed, right? And then we place it into the remove queue. but the rest of this seems kind of unnecessary. Which libraries do I use? I'm currently using Vulkan Bootstrap for setting up like the Vulkan device stuff. Just raw Vulkan for actual rendering, Tiny GLTF for parsing GLTF models, GLM for math, and that's about it. I was using eNet for networking, but I'm not currently because networking is also scrapped right now. Okay, I'm starting to see the problem. This is a terrible function. If the new node emits light, add the light. So if the new node emits light here, then we need to create a light, copy the light out into there, set that it's special because it's a light source, then we push it into the light add queue. Then finally, if the new node is transparent and the old node isn't, then we want to propagate neighboring nodes onto it, which I think makes sense, and I'm not sure if that was working. I want to confirm that that was working. So if I give myself a torch, then I set it to dark. My blog site, oh, thank you so much. I'm glad you like it. So I was a web designer for like many years before like actually starting, like I was doing it before I was in university. I started at like early high school, and for some reason local businesses actually trusted me to manage their websites. And I really love web development, and so I had a lot of fun putting that site together finally after not having a website for many years. I'm glad that people are actually looking at it. Thank you. Am I using deferred or forward shading? This is all deferred rendering. It's actually a really funky system. Here, I'll show it to you. Although first, I do want to note, look, it's working. So we at least know that the light propagation into newly transparent nodes is functioning. Let's take a look at the render step real quick. So if I pull in... Wait, am I actually on release, or am I on release with debug info? I'm on release, okay. So if we open the game up here, it runs super slow on your machine. Interesting. Do you have hardware acceleration off on your browser? A lot of people do that if they want to like share Netflix and stuff with their friends, and it completely screws like frosted glass and translations. We'll just throw a light there, and I'm going to take a snapshot of the environment. Okay, so this is an individual frame of the engine. It's on. When I tap back into it, it stutters for like 2 seconds. Interesting. I haven't encountered that myself, but I should probably profile on some more devices. Okay, so here's my main color pass for rendering chunks. If I go over to the texture viewer and we look at the outputs here and flip them so they're the correct direction, basically, so I've got a position buffer, I've got a normal buffer, and I've got an albedo buffer, and then I've got a depth frame buffer, and all of the chunks are meshed using indirect calls from the same like buffers, so each indirect call is basically just its own buffer worth of meshes that are within the view frustum. And then my indirect pass over here... Is this it? Where is the final indirect pass? I think it's this? Yeah, okay. This takes in the unshaded albedo and all the other stuff, so you can see there's no like normal shading here. And then it outputs actually normal shaded values. So it is a deferred renderer. I'm on an M4 Mac could be the reason. I wonder, yeah, maybe. I created a game engine in C# and I use a clustered forward renderer. I'm not familiar with clustered rendering. What does that do? What are you using for text rendering, by the way, when you type in commands? I'm using my own So I've got my own GUI system that only sort of kind of works, and I'm using lib freetype 2. Freetype 2. I'm using freetype 2 to actually convert my font files into signed distance fields, and then I have a special renderer for the GUI stuff to render them. Okay. I did actually change a couple things about the light propagation here, and I do want to confirm that I didn't accidentally fix it. Create clusters or chunks for the lights and render only the lights in the nearby clusters. Interesting. Whoa, okay. I appear to have just straight up broken it. But that didn't break for this, right? Yeah. Oh, well that's a new one. Okay, that's weird. So, what did I change that broke that? Was it the fact that I did this stuff? Besides that, it's forward normal. Got it. Cool. Give Zeus default light cyan. Okay, so that, yeah, so something I did here broke it. So, if old_def.emits light or old_def.transparent and not def.transparent, then I set the existing light value to special. I'm gonna try something. I'm gonna go if old_def.emits light set special light. Because I think that's probably it. I think the light being propagated out from placing the cyan light needs to know that it was special, because otherwise it's going to be stopped by the fact that that light's opaque. Confirming. No, that still didn't work. Interesting. Very... I think I get it. Wait. I don't get it. Oh, oof, hold on. Is var a homegrown variant class? No, it's just a macro to auto. I have let, which is a macro for const.auto, and var, that's a macro for auto. Okay, what is exactly happening here? So, when an old definition emits light, or an old definition was transparent, and the new one isn't. So basically that's what's going to happen when we place down a solid light source. The old block was transparent, and now the new one isn't. Then the first thing we do is we copy the old chunk light value into our light property here. Then we set the block there to be opaque, which if it's not transparent, which is correct. Then we create a light value from... So then we create a new dark value into here. And then we set special on our new light, which I'm gonna confirm... this isn't necessary, because it shouldn't be necessary. Because if the old definition emitted light, then the new definition should, or like then the copy should also be special. It's Next.js that's slowing you down. I mean, it should just be static though. One call stack is over 300 functions long, huh? But that should be asynchronous. Okay, so confirmed that I don't need to set special here, which is good. So we copy the light out, then we set the existing light to be opaque. But that, again, shouldn't do anything because we're recreating the light right here. Like, that should be clearing everything. It's preloading things to do tab and then scroll. Yeah, that's a Next.js thing. It will, like, basically try to identify links that are on screen and preload, like, partial content for them. Okay, confirmed that setting that opaque property does nothing on here because we're recreating it. Although it should do it down here so that it is actually caught up, but that's probably going to break our light propagation. Let's find out. I think I know effectively what's going on. Yeah, so that's setting it opaque, but we also should be setting it to be special if def.emitsLight or def. Oh god, what is the semi-permeable value? Light factor. Huh. Interesting, okay. I don't see where I actually set special for that. Maybe I just don't have that implemented yet, but this should cause it to be able to propagate out, I hope. Do I have greedy meshing in my engine? Yes, I do. It's currently off because it doesn't play well with the lights just yet. I have a system I'm planning on doing to integrate them, but I do have greedy meshing. I have a whole video that I put on my YouTube channel about it, actually. If you're interested. I see you're on the Twitch side of things, so I'll quickly throw a link to it in there. Where is it? Right here. Okay, so Zeus default light cyan. Okay, that properly spread. So the problem, I actually did fix a bug here. The problem was that I was trying to set that the new position was opaque, but I was never actually doing that because basically I was not, like I was clearing it after I was setting that bit, but as soon as I set it to opaque, it broke because it was a light source that was opaque, and it didn't know it was a light source, so it just wouldn't propagate lights out of it. So I also had to set that it was special if it was a light source, so it would still compute the node. Am I taking BF applications? Not currently. So if a new node emits light, add the light. So if it emits light, then we're going to... Oh, but that's only in the remove queue. So that's really interesting. That's... Okay. I think I kind of see the problem. The problem is as follows. If I go over to the nodes file, and I set this to transparent, and then I do this, and we grab a cyan light. You never did the tall grass optimization? Yeah, it honestly saved a lot of computations. Fuck, it still didn't work. What the... It only did one node. Huh. That's super weird. That is super weird. Did it actually update the code? I guess I should confirm that. Zeus default, light cyan. Okay, I really thought that would fix it. Well, let's look at this in a bit more detail anyways. How do I update my shaders data? I mostly use push constants with pointers to like device buffers on the GPU that contain states and stuff. It's like it's definitely a Vulkan setup. If you're on OpenGL, that's going to be completely different. When I try to make a new game, I always end up facing basic life existential questions and having to make a whole essay explaining why something would or wouldn't work. I really wish that I could like very quickly identify this problem, but it's like such a mess of things right now that I'm just like, ooh, okay, hold on. Removal step. Did I miss a message? I feel like I missed some context. Okay, so this adds light, and this adds light. Okay, so remove light from this position if there was... Remove light from this position if the old node emitted light or was transparent and the new node isn't. Then, so let's assume that that's the bug. Then we also have if the new node emits light, okay, add light if the new node is light emitting. So if emits light, then we set special, we copy the light here, we stuff it in there, and we call in placing into add queue, and then remove light if the, or wait, so hold on, add light if the new node is transparent and the old one isn't. I think that's all of the context. So I guess as a very simple thing, let's go if old def.emits light, or if not, or if old def.emits light, we're gonna return right now. So that should basically make it so that if the old definition was the light block, then we only hit the removal queue and don't hit the add queue. And I'm curious right now to see if that is the issue, because it might be that I'm trying to remove the light, then the algorithm is kind of screwing up, and then it's immediately re-adding the light back. Add light. Light is still there. Okay. It also didn't... So it cleared the light value of whatever's in this cell, but it didn't propagate. So we can confirm that it got here, then it created a new light value, then it probably didn't set it to opaque, then it probably didn't set it to special, and then we placed it into the remove queue. For example, why don't we have forever games, and how to make a game with a satisfying ending? Those are real questions you ask for yourself. It's true. I had to really go through a lot of thoughts about that when I was making this game, because, you know, it's a sandbox game. It's very easy to be like, well, Minecraft kind of doesn't have a purpose, and it goes on forever, so maybe I should make a game that doesn't have a purpose and goes on forever. And I think that's, like, especially present in beta, where that's literally all you do. Like, there's no bosses, there's not much progression beyond diamond tools, and, like, that's my preferred version of Minecraft to play. That's why I opened it up first earlier when we were talking about light propagation in Minecraft. But I also have to acknowledge that when you have a game that doesn't have a goal, you sort of end up in a situation where it's the same as any other game that doesn't have a goal, at least the mechanics are the same. And I think we've been seeing a large saturation of sandbox games that kind of do that, like, in the last several years. And there's not much actual draw to play them, because Minecraft did it already, right? Like, an incremental improvement to the space will not replace the familiarity people have with the systems they already know and love. So I don't have any interest in trying to recreate a forever game the same way as Minecraft, which means I needed to figure out how to contort those sandbox mechanics, which are intrinsically sort of like unfocused and undirected, into something that would be able to have a purpose and a narrative and a conclusion. You have 3D animations already. Yes? If I spawn a rabbit, it's really hard to see because it's fucking moving around everywhere, but it does have an animation. It's just an idle animation though. But like, I do support animations. Are your leaves translucent or punch through? They are not translucent. They are just transparent in places. I do have the kind of Pocket Edition style optimization though, where if a leaf is surrounded by other leaves or solid blocks, then it becomes opaque inside. Which I honestly think makes the environment look a bit better anyways, because I guess I don't have any in here because it's all like scraggly. It just makes the entire tree look a lot more solid in my opinion. Okay, so we know for a fact that the remove queue is getting placed into, and we presumably know that the remove queue is running. Where is my log here where it says light queue finished in whatever iterations? Iterate nodes modified chunks dot size. If I place down a light and then break it, 1 node, 0 modifications, 1 chunks. So it processed exactly 1 node and stopped. So let's look at the remove queue real quick. We grab our node, we grab our light. Then we grab the chunks light. And then if the light that we already have is not special, and the existing light is opaque, then we continue. But that shouldn't happen. So let's just go log confirming got past here. I'm actually going to do a warm, just so it's a different color. Okay, place, break. Confirming got past here. Perfect. So we know that it got past that point. Then we store the old chunk light by copying it in. I don't really like how this works. I'm gonna tweak some stuff. I feel like this is prone to fuck-ups. I'm gonna go like this, and we're gonna inline a bunch of this. And then we're gonna pull in old chunk light here, and then out into this vector. And then that there, and then we're gonna rename this to chunk light. So we're storing the initial value of the chunk light, then we're removing from the chunk light our light value which we want to remove. Then, if the light is not special, and the light is equal to the old chunk light, then we continue. Now, I'm gonna write into here, warn lights were not equal. But they are equal. You know why they're equal? Oh, you know why they're equal? Because we're setting the light values light to 0 in the propagator, and that is causing it to be set to 0, and then when we subtract the old light, it's still set to 0, which means it's equal. God damn it. Okay, so that's probably the issue, or at least that's one of the issues. Let's go back to our recalculate light, and we are not going to reset the light at this point. We are going to, or we're also not going to do this, but Interesting. So the issue here is that if I don't set this light to 0, and then I go on to remove it, I'm also not setting opaque or special on the new light value. Which means that after the light propagation happens, we don't know that this is a light anymore. But that shouldn't matter, because in the add step, we set it to special. Yeah, that shouldn't happen, because in the add step, we set it to special, but we don't set opaque, which is potentially a problem. I think... Okay, yeah, this is genuinely really difficult, because currently we have the issue that... Oh, maybe that's why I set special. Hold on. Let's reset the light. We'll set it to opaque if it's opaque. And then, if the definition.emits light, we call set special. But that's not what we want to do. We want to go with old def, or we just actually want to set special on the old light. And this is gonna go set it here so the remove queue continues even though no light was removed. Then if we go back down to where we flush the light queue, right here we go if not light dot is special and it's equal, we continue. So now that we set it that it was special, it should be able to actually continue even though no light was changed. In this case, in the remove queue, the special property is used to say whether we should continue onwards even if we're, you know, not making any changes. I mean, one of the biggest things you always have to have clear definable objectives. The thing with games often is that it traps you in a game loop and prevents you from doing intentional cycling, which is essential. Infinity is to be avoided. I agree with that. That makes a lot of sense. Fuck, why didn't this work? No! What the hell? Hold on. So, hold on. Let's go crop past the barrier and then adding a light emit node. I'm having a moment with this code. This is... Oof. I think we're getting there. I think we're almost getting there. So if I do this, go past the barrier, adding a light emit node. So, but it didn't emit light, which means that it went into here. We set the special property, then we're emplacing the value into the add queue, but it's not being added. So let's take a look at the add queue. So we grab the light. We grab the light, and then if the current light is special, then we multiply it. Otherwise, if the light is opaque at the current light and not light is special, light, continue. And we're gonna go, if the position is opaque, then don't propagate light unless the force special bit is set on the propagate node. See, I even had this case here. It's just, it wasn't in here. So that's just great. Alright. Let's try it again. Like you can translate the world's game mechanics into activities. Do you know of an activity that goes on forever? Not sure I do. A restrained sandbox with limited rules doesn't allow you to grow as a person. Interesting. So, like you're saying that a game that tries to run forever because it's constrained eventually ceases to have value. Ignore that. Do you see what I see? It's almost working. I don't know if I intrinsically agree with that on all scales. Like, I think that that's often the case, but I think a lot of the things that sandboxes do is they create spaces for creativity. And if there is ever a task that does go on forever, I think creation is one. And oftentimes creativity is most valuable when it's born of limitation. So I don't know if I entirely agree that, like, it doesn't let you grow as a person. I do believe that there is, like, you get kind of diminishing returns, maybe? Okay. We are living our best lives here. Lights are actually going away. I mean, kind of. They're kinda going away. Game done, let's ship it. Like, look at that, it's here, and now, shush, it's not here. If we look directly down, it's not here. We don't see any of this stuff. So basically, winning. Okay, in all seriousness though, we do need to figure out what's going on here. I'll give it a little bit. I'm worried my brain might already have been melted too much by the existing stuff that we're looking at. It looks good to me. But I'll see what I can do. So, it's not only checking its own Y level. There's something going on other than that, because this was on its Y level. It has to do, I believe, with how I'm propagating the removal nodes. I'm not quite sure what that issue is yet, though. Because we can see... Also, this isn't getting populated with the skylight again, which is interesting, but that's also not the same issue. So, if we get into the remove queue, so let's actually look at how the remove queue works. Because we know the add queue works. Actually, let's take this a bit further. Let's do a split screen. Alright? And we're gonna have the add queue over here. And we're gonna look at the remove queue up here. And we're basically just gonna compare them because they are essentially supposed to be invertible operations. They should be doing pretty much the exact opposite thing. So in the add queue, we get the existing node. Then we get the light out of there, and then we pop it from the queue. Easy peasy. Yeah, makes sense. Then, interesting that we don't increase the touched nodes thing here. I kind of want to increase that for just profiling. Then I've got pretty much the same debugging stuff that I think I can clear. I don't think I need any of this right now anymore. Then... if the light is not special and it's opaque, then we continue. And yes, I did confirm that's only the light source. And we're gonna go, if the light if the light node in the chunk is opaque, and we aren't forced to propagate because the light node, because the node is a light source, break out here. So that's if the light is not special and it's opaque. Then, so the old light, because we're never going to change it, I'm going to call this cur light, just like over here, so it's simpler. We have this cur light value, which isn't initialized here and is here. That shouldn't make a difference, but I'm going to initialize it anyways, because I don't like undefined behavior. Then we're copying the light in from the existing chunk. Yep. Then Interesting. So we immediately remove the light value, the light value from the current light here. So we're skipping the is special check. And we're effectively doing this check up above. And I'm trying to think of why that would be the case. Because light is opaque and not light is special. We should be able to do basically this check here, first of all, because then I don't need to index into this pointer again. Undefined behavior, my love. I'm not writing safe ever. Okay, I do like undefined behavior sometimes, but not in something like this. This is way too complicated. And we're gonna run the is special check up here. So if the current light is opaque and we're not doing is special, then we don't need to do this. And it's interesting that this block here was initially blocking that from getting run. Because if the current light is special, that just means that it was a semi-permeable or a light source. Either way, though, it shouldn't make a difference, I think. So let's just keep that gone, and we're gonna discount this as... We're actually gonna comment this out for now, because we don't have semi-permeables working. Working on an MCU right now with an LVGL library, and everything is just raw pointers, so that's pretty much a high-quality safe standard. Yes, yes. Those were certainly words. I don't know the acronyms, but yes. When I started on, like, working with C++, I was like, wait, pointers can be moved for free? I should just make everything a pointer. And I didn't know smart pointers existed, and I just used raw pointers everywhere, and it was terrible because I had no memory locality. Okay, so this remove is basically analogous to this merge. So we're gonna go remove the lights, remove lights, the existing light where our remove node is greater or equal to it. Sounds like you need Rust. And then, if the light was not special, and the light is equal, then we continue. So if there was no effect and we're not forcing propagation, continue. Cool, still analogous. And I'm gonna go down here, modified ++, because apparently there's more profiling stuff that I don't have set up. MCU is a microcontroller unit and LVGL is a GUI rendering library. Ah, cool. Okay, then we get down to our new lights. Our new lights are being generated the exact same way as we're doing them in the light add zone, which is important. That needs to be the case, and it looks like it is. Then we get the local position. Then this loop is quite different here, so let's take a look at that. Hello there, greetings from Brazil. Hello there, greetings from Canada. I was just wondering, is your bachelor's thesis open source? I didn't have a thesis. I'm assuming you're talking about my honors study? Did you find my honors study video on my second channel? If I go over to that... are you talking about the... Oh no, it's speaking. Stop speaking. The emergent game control methods on the web? This video? Because if so, yes it is. There's a link in the description to the source code. Canada, Quebec? Nope, Canada, British Columbia. West Coast. I'm never ever showing anyone my master's thesis, unimaginably bad. No, I mean, can I look at your thesis? Some unis publish those. No, I didn't actually have to do a thesis for my bachelor's degree. But that YouTube video I sent is basically my presentation for my final project for my degree, so it might be similarly interesting. Hey Tomorrow, when I read the title I thought you were deleting your lighting implementation. And hello! Yes, I am making it so lights can be deleted, but I'm not deleting the lighting implementation. Exactly, it's even greater when you're debugging and it's just a simple backtrace of the machine commands in hexadecimal. Ooh, that's rough. Someone else said Canada where? I think I already replied to that, but British Columbia. Okay, so let's look at these things. So we're gonna get the position of the adjacent node, get the new light from it, and then we don't want to continue. Oh yeah, no worries. We don't continue if the light is 0 on that side, but we do on this side. Do we have a check for is 0? I guess that's just if nothing gets changed. Then we check the position of this, and then our new index is computed. It should be computed using the same math here. I guess let's actually find out if that's correct. Did I do this properly? 5, 6, 3, 4, 1, 2. So that should be identical if I go blump. I mean, other than like the indentation changing, that is correct, yeah. Then we grab the adjacent chunk. If the adjacent chunk doesn't exist, then we create it. Then we skip if that is not correct. Then we emplace into the remove queue. I remember why this is broken. I remember what's going on. And it's gonna be messy. So basically, let me create an example here. We're going to see a very interesting pattern emerge. So if I place this light, remember how I was talking earlier in the stream about the octagonal pattern basically being handled by tracking the direction that values come from? That is done basically by, like, sometimes nodes will go over themselves multiple times and update it. It's part of the reason this system is more intensive than a basic lighting system like Minecraft has. But like sometimes it needs to traverse the same area multiple times. And you'll notice if I delete this light, it's always interestingly going out in one specific cardinal direction. And I believe the reason why that's happening is because when I'm removing the nodes, I'm not storing what bits we've gone through and removed them from, like what directions. And so when I go into my code up top here, and we go if the light is equal, and this does like a true value equivalency, on the add step, that isn't true if we've just entered in from a new direction because we've set those bits. But in the remove step, if I go back to the dimension, in the remove step here, we don't preserve those bits at all. Because we actually clear, or wait, we keep the flags. Wait, dir mask, value mask, not flags mask is dir mask. Oh, flags mask is opaque and special, so that's irrelevant. But the point is that value mask here, I don't believe is actually respected, because when we go to remove, we go negative direction size and then channel size. So that's grabbing the entire channel, including the bits. So basically what I need to do here is I need to unset the channel bits specifically where the remove node had them, I think. And I'm gonna try that in a sec. The clickbait title got me, deleting your lights, you absolute mad person. No! I know, shameless clickbait. I'm just making the light deletion work properly. Okay, so I think if I get rid of that, and then I go value size, this is going to still not work, but it's going to not work, I think, in the exact same way. Because basically we were removing the bits before, which was going to make it equal no matter how many times we did that. But now we're just not even touching the bits, which is going to make it also not change. So what we effectively need to do is do an additional step where we clear the bits from anywhere that was less than... Huh, that is going to be interesting. But let's confirm that I'm right, that this is a no-op, basically. Yep, same bug. So what we need to do is when we remove, we need to also create a mask. Okay, so I'm gonna try this out in a pretty inefficient way first, because I don't know, I mean, like, it makes the most sense. So first of all, I'm gonna leave this side down here exactly the same, because this is just sunlight propagation, and we don't need to do this on all three right now when we're only messing with block light. So this is our actual, this is our block light, okay? And we're gonna go channel preserve mask, and then dir preserve mask. And we're gonna go channel preserve mask here, or, so in 0 and channel preserve mask, or direction mask, which is that one. In fact, actually, instead of doing it like that, we're going to go or dir mask in here, which means we're not going to delete any of the direction bits. Now, in here, we want to basically remove the directions in here. So we're going to go out 0 is equal to in 0 and dir preserve mask. And this dir preserve mask is going to start at -3 and go dir size, which should be equal to 3, yeah. And then by default, that's going to be fine. So this should again be effectively the exact same effect. So nothing is fixed. But what we're doing now is we're effectively always keeping the direction bits for the, all of the channels, right? And then we're creating a separate mask here, which is only keeping the direction bits for channels where we didn't remove anything. Only keeping the direction bits for the channels that... Oh, that's actually going to break everything. Hold on. I mean, let's confirm, but I'm pretty sure that's going to fuck everything up. Well, I think I crashed the game. Or something. What did I do? I created a memory leak. Hold on. Stop. Okay. That might have destroyed the universe. Interesting. Why would that happen? So, out 0 is equal to in 0 and dir preserve mask. Yeah, C++ moment. And we're also going to do in here or value mask, which is all the values. Okay, let's try that again. So, I love bitwise arithmetic. It's my favorite thing to do. Totally. Waiting for the compile time. So basically, this should work, but do nothing. And then we're going to continue this logic outwards and basically do some other stuff with it. Okay, no, we still got the memory leak. Interesting. So why is that happening? So our channel preserve mask is the less than mask from 0 to value size, and we already confirmed that that is a no-op if we just do that, right? So this is going to be effectively just the value mask. And just stopping by and I see this bitwise hell. Yeah, this is probably the most horrifying part of the code base right now. Lighting stuff is super deep into using word level parallelism to store multiple integer values in one int and manipulate them simultaneously. And it's pretty bad. Is this project open source? Not this one, sorry. I want to eventually make a commercial release out of it, and I've put far too many years of my life into it to potentially have someone just take it. I have a lot of open source projects on my GitHub, just, you know, not this one. Oh, interesting, so this is still borked. You're all here for it? Hell yeah. Okay, what have I done? What have I fucked up? So the only difference between this line and this line is that we've got the dir mask in here, and we're not going to -3, but we've identified that -3 shouldn't be affecting anything. So how is the dir mask breaking it? Because if we're just saving the direction bits, I'm potentially seeing it. I'm potentially... Because if we save the direction bits, then removing a light node from it won't necessarily set the direction bits to 0. I think. Oh. Or it's actually just broken. Hold on. Hey there, Rushback99, how you doing? Okay, wait, so if clearing the direction bits is necessary, that kind of says something. And I think what it says is that I'm maybe using too precise of a deletion method, maybe? I don't know. How about yourself? I'm doing good. I'm doing good. We managed to fix some bugs with the lighting system today. Lights were previously not able to be gotten removed at all, and now they are getting removed. Whoa. Okay, we're still broken. Okay, wait, hold on. Now I'm very confused, because this is the same line as this. Hold on. So that's negative dir size. And my code was -3. Hey Playtester TV, how you doing? So what is dir size? Dir size is 3, isn't it? Yeah, it's 3. What IDE am I using? I am using VS Code. I'm actually trying to figure out in what way this is different than this code above. Because it... Ooh, value size, I see the problem. This needs to be channel size if it's set to -3. So confirming then, if I set this to 0 and then set this to value size, in theory this should be okay. feel like I'm a scrub now because I'm using editor. Editor? Like... Wait, like, what do you mean? Like, just Notepad? Oh, is that a Mac program? Is that what Mac calls its Notepad? Windows editor. Okay, so Notepad, right? Like cyan. Okay, that plays properly. And if I delete it, I didn't delete properly, but I mean, hey, if it's probably a good idea to expand your IDE situation, even if you just get like Notepad++, it's got a lot of nice features to it, but like VS Code is free and open source, and it will do so much for you than Notepad. Tell me you Rice Linux without telling me you Rice Linux. Because of the drop-down terminal, it's super useful. How do you handle memory management for world chunks? Currently, I'm just storing them in a hash map, which is not ideal. In the future, I want to set up an octree type situation. My earbuds are about to die. Give me a sec. I need to swap these to a different pair. Hear me out, just recalculate the lighting for the whole world every time a block is placed. Ah! Okay, my own voice started playing from the video I linked earlier. Okay, wait. Is the audio coming through? Can you all still hear the music? Hash maps, if you're using them right, are kind of fine. Octree dereferencing can have huge cache misses. I want to implement LODs though, so using an octree would be very helpful for that, for like spatially storing the levels of detail. So... okay, good. Music is still going. Alright, so this is still working, which is what I would expect. Now if I do this... this should now cause the memory leak again, because removing the light will not erase the direction mask, which is not what we want exactly. Scoff, memory leak, cough, rust. This is a memory leak that would still occur in Rust. It's just the nodes keep expanding. It never actually finishes. For LODs, there's plain clip maps, so the same leafs but without links. Interesting. I don't know about that. I should look that up. Okay, so that deleted it properly, even though the dir mask was preserved, which is a bit weird, actually, if you think about it. So our dir preserve mask is -3 dir size times flags mask or value mask, and then we're also going to go and multiply all of this, or, well, and it with remove and dir mask, and then I think that won't break, but honestly I'm feeling a little bit brain dead right now, so this might be bad. Also, I'm exploding everything. I'm sorry, I didn't mean it. Oh shit, thank you for the tier 2 sub, Sith. 24 months, wow. It is Pride Month, you know what that means. What, that I'm extra gay? Found out there's a method on the vex struct in Rust that leaks all of it. Oh, weird. I assume it's unsafe, right? I hope it's unsafe. Gay meth. You highlighted that message. Okay. Sure. Hey, Flightman. Alright, let's try and place a light. Does it break? It does not break. let's try and remove a light. I'm going to sneeze. Hold on. I'm holding it in. I'm containing the sneeze. I'm okay. Okay. Kill the light. Oh my god. Wait, it actually went away. Whoa. Wait, hold on. I wasn't expecting that to work at all. Light killed. Light killed. Light killed. What the fuck? Zeus default. Light red. Okay, these are entirely non-intersecting lights. Okay, that broke everything. I think that's memory leaking. It's not leaking, it's just broken. Interesting. Hold on, is that because I placed an intersecting light, or did I just break red lights? One of those things is a lot funnier than the other. Oh. Okay, I seem to have just broken light intersection as a whole. Great. That's perfect. Honestly, I don't know if I have the brain cells left to figure this out today. I'm going to, I think, leave this as is for now. And I'm going to just say, hey, look, we got light removal at all working. There seems to be a new bug with the light intersection. I'm assuming it has something to do with, like, the exact value equality, once again, being funky. In fact, actually, I'm pretty sure I know exactly what it is, which is that once the light gets set to 0, with this system, it's still preserving the direction bits to an extent. Which means that sometimes when a light value is 0, when we're adding nodes, the direction bits are not set to 0 properly. Which means I'm gonna need some extra logic, basically, to clear a direction bit if the light value is lower than the current value. Which I honestly thought I already had, but doesn't seem to be working. I'm gonna write this removes light sources properly, but breaks re-adding intersecting lights, presumably because some of the Duramask bits are left over on the lights that have been deleted. Probably has something to do with strict value equality checking in the light add step. Check that next time, dork. And I think that's great, dying inside. Yeah, a little, but it's fine, it's fine. I think that's gonna be the last of the programming that I'm gonna handle for today. I am quite sleepy, and I also want to eat lunch, so yeah. I think I'm gonna save that for next week. If anyone has any questions, feel free to ask me now, and I will do my best to answer them. Otherwise, if you'd like to catch the next stream, I'm saying this because there's a lot of new people in the stream right now. I stream every Sunday at noon PST. Although I'm not going to be doing it next Sunday because I'm going on a brief vacation to my hometown for the weekend, which is going to be nice. See my family. But I'll be back 2 weeks from now. I post stream announcements in my Discord. The URL is here. And I also simulcast to YouTube. So anyone that's on Twitch, I also have a YouTube account where I post videos. I have a new heavily edited video on voxel meshing that is almost done. I've made like 6 minutes of completely original animation for it, and it's taken probably about 40 hours of animating at this point, and I'm very tired of working on it. But yeah, it's it's coming to a close. It's going to be uploaded soon, so if you're interested in seeing that, it'll be there in a bit. And there's also the first episode of that voxel meshing series already uploaded, so yeah. I understood making an engine and in voxel, but why make another copy of Minecraft? I mean, I'm not really. Like, there's no gameplay yet in this game, so like, you know, obviously the basic core features of having voxels and placing and breaking them are all you can really see here. But I have a lot of unique mechanics that I plan on implementing that are going to make the game flow very different from Minecraft. I'm just a huge fan of being able to manipulate stuff in voxel space. I think it's a really... Like, I simultaneously really like the aesthetic and the creativity that it affords, so the basis of my game is the same. Bees? Bees? Oh, bees. Yes, bees. Bees in the game. There might be bees in the game. Brian and I had a long talk about bees one day. But yeah, no, I have a very different actual gameplay idea going on. Do I prefer Vulkan over DX12? I've never used DX12 because I'm a Linux nerd, and DirectX doesn't support Linux. So I guess, yes, by default. Yeah, I like, on principle, would not want to use a graphics API that isn't cross-platform, that just feels needlessly restrictive. And I mean, I do very much like Vulkan compared to OpenGL, although I don't think that's much of a contest, because OpenGL is quite horrible and ungodly. Yeah, but next time we end up on stream together, I am probably going to be working on making it so that placing multiple lights that are intersecting no longer breaks anything, and I'm sure that that's going to introduce new and unforeseen issues to light removal as well, which will be awesome. Did I just, like, perfectly place this in between, or I wonder if it's more of a specialized issue? Oh, wow, that deleted all the lights in the chunk. Uh-oh. I might have made a terrible error. Huh. Are all lights just getting deleted? That are within the same chunk? Interesting. Okay, yeah. Yeah, we might not have as good of a system here as I thought. Good refactoring today, thank you. We are adding total light deletion. Yeah, so... Yes, next stream I'm gonna see if I can figure out the math behind what the light removal's meant to be doing, and then actually get the light deletion to be doing what it's supposed to, and get the light addition to also be doing what it's supposed to, and then everything can be doing what it needs to be doing, and it'll be perfect. But until then, yeah, I guess I'll see you all next time. Join the Discord if you haven't, we can chat. Other than that, have a great day, everyone. Thanks for hanging out. This was really fun. I always love doing these streams, so, you know, it's always nice when people are in the chat and asking questions and things. It makes it a lot more engaging to work on stuff that I would otherwise put off, like lighting, because lighting is evil. Yeah, look at that. That is intersecting. Weird. Bye, everyone. All right, cool. See you all in 2 weeks.